Yeah.
Okay, so what's this first one look like? What do I need to start off with? 6 carbons? 2, 3. Oh, that's not working. 2, 3, 4, 5, 6. Okay. What else?
Chlorine, you need an aldehyde on the end and a chloral on
Are we okay with that? If you want to put an H on the far side, that's fine. Don't need one since it's a line structure. Good with that? That one okay? That work? All right, so what's the IUPAC name for this first one?
propanol.
No.
Propanol.
Yes. And the common name for this one? Propylaldehyde. What's the IUPAC name for the next one?
Butanone.
Okay. And the common name for it?
Oh,
No?
yeah. Ethyl, methyl.
And this one here? 1, 2, 3, 4, 5, 6, 7, 8.
Or octanol. Butylpropyl.
Do you see that we haven't accounted for all 8 of the carbons with the word butyl and the word propyl? That's only 7 of the 8, but the ketone is referring to that carbonyl carbon specifically, so then you do get your 8 total. This one? That work? What's wrong with 2-bute now? It's an aldehyde.
Now, on the end.
Yeah. So this is probably, there's a mistake. It was probably a ketone that the person was trying to describe. And what's wrong with this structure here? 5 bonds to carbon? Yeah. Okay. What about it?
Like, how much the yeast spits out alcohol, so like cheaper than yeast,
Type of
strand of the yeast.
Yeah, it's definitely strand of the yeast, but what about the strand of the yeast?
How much- How much?
How much alcohol it gives out.
Yeah, hardiness. So if it can sit in its own pee longer than another yeast, then your beverage is more alcoholic. Is that always the case? Is one wine more alcoholic than another wine because of the yeast? Or is there a possibility of another factor?
Doesn't matter like how long they've been sitting around.
Running out of
Sugar.
Nah, it won't be an issue. That'll just be if it's dry or not.
Oh.
Really bad wine has the alcohol that the yeast produced and then some extra alcohol that they throw in
Cool.
just to make it more alcoholic. So what are those referred to as?
Cheap wines.
They're fortified wine, of which Mad Dog is a
Mad Dog, you say?
Mad Dog
I
is.
heard that.
That's what you did, you drink that when you were like a teen cop?
No, I did not. I didn't start drinking that.
They-
Big boss.
They simply ferment bad wine, and then after the bad wine has been fermented, they toss in some extra straight grain alcohol just to make it more alcoholic.
I know people that drink it, yes.
Retrosynthesis, write the full equation for this thing. Okay, so let's start off with what the thing is. So what do I have to draw here? Octane. All right, so there's an octane. What do you want to do to it? On the fourth carbon, I want to put a methyl group. So 1, 2, 3, 4. Actually, I'm going to do this.
Turn it, aren't you?
2, 3, 4, 5, 6, 7, 8. There we go. So I've got the octane part. I've got the methyl group coming off of number 4 on the octane. What else do I need?
Put an oxygen at one.
Where am I going to put that?
At one.
No.
Number
At 3. At carbon number 3, I'm going to have a bond going to an oxygen.
Then that bomb's gonna connect to a butyl on our second part. Yeah. That one was a pain in the butt, by the way, for me.
Okay.
I struggle with it, but
So retrosynthesis is what organic chemistry students spend half of their time doing. So what were the reactants to make this? Did we not do this part here?
well.
Yeah, that's what we're.
So I put like
We're gonna
an
go back.
octane with a ketone group on 40, I think. Or I forget. And then a triple double bond.
What molecule did we make?
Three sec butyl IC.
Type.
Huh?
Type.
Make what?
We made an ether. And what do you need to make an ether?
And oxygen in between two carbons.
So what do you need to do to make that? You need 2 alcohols. That's how they connect, via the alcohols. So the water molecule is one of the oxygens of one of the alcohols on one of the molecules. Both the H's from the alcohol group left, leaving one of the molecules with an oxygen with a missing bond and another molecule with a carbon with a missing bond, and then they connect. So if this is the molecule that I just made, this oxygen right here used to be an alcohol, and the other carbon that it's bonded to also had an alcohol on it. So this little piece right here is this little piece right here with that OH gone. And then this piece right here is the rest of the molecule. So I hook them up because they both had an alcohol group attached to them. And water left, leaving an oxygen carbon, or carbon oxygen carbon bond. T-butyl methyl ether. So what do I need with this? I need an oxygen, because it's an ether, and then I need a methyl group, and then I need a T-butyl group. Or that. Are we okay with those drawings? So pentane 2, 3, 4, 5 SH. That's it. Two butoxypentane. Okay, so this name is what type of name? It's the IUPAC name for an ether, as opposed to a common name for an ether. Okay, so when I'm doing the IUPAC name for an ether, I treat the that ether kind of as a side chain. So what do I have? I've got a pentane. So 2, 3, 4, 5. And what do I have attached to it? On carbon number 2, there's an oxygen. And what's attached to that oxygen? 1, 2, 3, 4. Good. And I've got 5 ethoxy 3 octene. Okay. So 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So there's a double bond from carbon number 3 to carbon number 4. And then on carbon number 5, 1, 2, 3, 4, 5, I've got an oxygen. And attached to that oxygen group, I've got 2 carbons. Can you see why the IUPAC naming is a little more superior than the common naming? The common naming would force a person to see this oxygen and say, okay, that's an ether. There is one side of the ether, so that's an ethyl, and then this is the other side of the ether. What the heck do I call that thing? I can't. There's no systematic nomenclature for a common name, so I can't do it. So it's a lot easier to use the IUPAC naming with this. Sometimes the IUPAC naming is a little clunky, and sometimes it's just necessary to lay out exactly what you have. Why are aldehydes and ketones more reactive than the alkenes? That's why right there. Because that oxygen is there, that oxygen becomes negative, and that gives that thing ability to have other stuff latch onto it. Trivalent aldehyde or ketone with at least 5 carbons. Okay. So I'll just do CH3, CH2, 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 C double bond OH. Don't act like you haven't seen all of those symbols before. What's this the symbol for?
Alpha.
An alpha particle, right? Yeah, it's a Jesus fish. Yeah, you're right. What's that? The beta. That one. Delta. Yep.
You could clean a pen chip on that. Or to identify that triangle, it looks like a sideways something.
Candy corn.
Lazy D.